Hey guys, welcome back. We're in the third video for lesson number 4. This is the chain rule with polynomial functions. Notice that right now we're just worrying about polynomials. The chain rule, I have to tell you guys, is going to be used so much in this class. If you took AB last year, you guys know how much we use the chain rule for basically every derivative. It is the most important one, so it gets its own little video. I just want to say that this is the actual definition for it. And just like before, guys, it's always stressful to read, the calculus definition and be like, what the heck is this? So I'm going to show you guys with a very simple example before I get down here to the bottom. But let's just read what it says. It says if f of x and g of x are both differentiable functions, and h of x is the composition of this. And what this really just means is that I've got function inside of a function. So let me really quickly, before we get to this part right here, let me just show you guys a really simple example of our function. So h of x is equal to, I'm going to do 3x minus 1 to the third power. Okay? So in this example, the f of x function is going to be x cubed. And then the g of x function is going to be 3x minus 1. And so if I ask you guys to find the composition, f of g of x, right, then that's exactly what you do. You take all of g, and you plug into f. You learned that in Algebra 1, Algebra 2, right? And so that's what this is. You take all of g and replace it into into f. So that's what this represents right here. So the derivative of h prime of x, so h prime of x, this derivative would be equal to the derivative of f, okay, with g still in it. So the derivative of f, and I'm going to do a couple of examples, guys. So if this is going to be confusing, I'm going to show you lots of easy stuff here. So the derivative of f is just 3x squared. Well, we need g of x in that, right? So we're going to replace g of x inside of our function. So we're going to replace x with 3x minus 1. And I'm going to show you the example in a second. It's much easier than this. I'm just showing you guys this whole crazy thing with this squared. And then we're going to multiply this by the derivative of g. Well, the derivative of g prime of x, is just equal to 3. So 3. And so this would be the actual derivative. Now that's really, really, really crazy. That's what this is. So that's the definition, is using compositions. We are going to find the derivative. But there's an easier way to do the problem. Okay, so now I made everything disappear. Let me show you guys the easy way to do the problem. Okay, so this is how I teach it to students. All right, so here's our function. We have something raised to a power. So we're going to go ahead and do the power rule. We're going to take the 3 and we're going to move it down in front of the function. So we're going to move the 3 down in front of the function, and then we're going to leave everything inside of the parentheses alone. You're going to leave it alone. So 3x minus 1. And based on the power rule, we're going to subtract 1 from the exponent. So 2. And then, ladies and gentlemen, once we've done that, then our attention goes in the inside. We have to then take the derivative of what's inside the parentheses. And so then we're going to multiply by 3. And this is exactly what I wrote with the composition. And so that's the much easier way to do the problem. You're going to take the 3 down in front of this. You're going to leave the function alone. You're going to subtract 1 from the exponent, again, the power rule, and then you're going to multiply by the derivative of what's inside of here. So if we look at this bottom question, this is, again, what we just showed you, or what I just showed you, right? It's just the composition. It's telling you what f of x is. It's telling you what g of x is, right? And so we're replacing x with what g of x is. And so we're going to do that, and we're going to find the derivative of f. Well, the derivative of f is this, right? This is one of those derivatives I told you guys, the square root of x and 1 over x. Know those really, really, really quickly. So it's just 1 over 2 square root of x. So notice what they did is they replaced g of x in here, which is this, and then they multiplied by the derivative of g prime of x. What's an easier way to do the problem, ladies and gentlemen? So let me show you guys the easy way to do it. So this is the problem that you're going to be given. You're going to be given that h of x is equal to the square root of x squared plus 1. That's the problem you're going to be given. You don't have to worry about doing the composition stuff. This is what you're going to do. So this is the question, and it's going to ask you to find the derivative. Well, the first thing I'm going to do before I start this problem is I'm going to rewrite this x squared plus 1 to the 1/2 power. So notice that I'm not finding the derivative yet, so there's no prime here. It's just h of x. I just rewrote it like this. So just like we did up here, ladies and gentlemen, and you're going to see it's going to end up being this right here. I'm going to find the derivative of this function. I'm going to first of all move the 1/2 down. There's no thinking here. The only thing that I got to stress, and I stress this every single year, with both a, b, and b, c is you have to leave what's inside the parentheses alone. Do not take the derivative of this yet. So when you're writing the function out, you're going to do 1/2. You're going to leave x squared plus 1 alone to the negative 1/2, right? We're subtracting 1, so we just use the power rule. And then, ladies and gentlemen, our attention goes to the derivative of this function. So x squared plus 1. The derivative is 2x. So if I rewrite this, and by the way, let's just really quickly notice that so this 2 cancels out with this 2. And so when I rewrite this function, I've got x in the top, and then I've got x squared plus 1 to the 1/2. It's moved to the bottom, right, because it's now positive when I move it down. And so it's just going to be the square root of x squared plus 1. And that's exactly what you see right here. So it's just an extension. The chain rule is just an extension from the power rule. You're basically going to have a function that's raised to a power where the derivative of the function inside the parentheses is not 1, right? It's not 1. So let's practice. Now, I think that you guys as BC students hopefully understood what I did here. So we're going to go and we're going to do 5 examples. All right, we're going to do 5 examples of our problem, and we're going to see if we understand it. So I'm suggesting that you guys pause it if you need to. Try them on your own. Sometimes you may want to rewrite things. Try them on your own and then see if you guys can simplify it. So pause it if you want, or just wait and let me do it for you. Okay, for example number 1, I want to find the derivative of this function. So, and I want to simplify it pretty much. And I know I keep talking about you don't want to simplify. You don't want to simplify numbers, but functions, usually you want to simplify them as much as possible. So I'm going to go ahead and rewrite this. This is the example we just did to the 1/2 power. And so I want to find this derivative, right? I want to find this derivative. So again, h prime of x is going to be equal to, I'm going to move the 1/2 down, okay, because it's raised to the 1/2 power. Leave what's inside of the parentheses alone. I know you're going to get sick of me saying that, but I'm going to stress it every single time because I still have students that forget and they want to do the derivative here. You leave the function alone. And then you're going to subtract 1 from the power. And then now you're going to multiply by the derivative of what's inside of here. Well, again, the derivative of a constant is 0. And so the derivative of negative 2x is negative 2x. Sorry, negative x squared. The derivative of negative x squared is negative 2x. Okay? And so we're going to simplify as much as we can. So we're going to see that the 2's go away with this. And so h prime of x, well, the only thing that's in the top is negative x. And then what's in the bottom is going to be the square root of 4 minus x squared. And that's it. That's all the chain rule is. It's one extra step from the power rule. All right, so hopefully if you try this on your own, you guys were fine with it and we're good to go. So if you didn't pause it, for example 1, you just want to see me do another example, maybe now pause it. You guys got this. I know you can find this derivative very easily, but let's go ahead and do it now. So y prime. Again, move the power down. 3/2. Then we leave what's inside of the parentheses alone to 1 less power, 1/2. And then we're going to multiply by the derivative with what's inside of the parentheses, right, which is just simply 4. Notice that this is a positive 1/2, so the only thing that can cancel out is that this 2 goes into this 4 2 times. And so our derivative, y prime, is going to be equal to 3 times 2 is 6, and then times 4x plus 5 to the 1/2, or y prime is equal to 6 and then the square root of 4x plus 5. And that is it, ladies and gentlemen. That is it. All right, so hopefully it makes sense. We're going to keep on trucking here with another example, but I'm hoping that through this process you guys are doing pretty well with it. Okay, so let's go on to the next one. Find the derivative of this. And so for this one, and you guys, I'm thinking now at this moment in time, you're getting bored with like, oh, another one of these. Yeah, that's kind of what they do. I mean, we do the chain rule. Right now we're just doing polynomials, or rational functions. This is a little bit different, but it will get a little bit more complicated, but not much. And I know you guys can all handle it. So y prime is going to be equal to, and I'm going to go pretty fast with this, right? I'm going to move the 1/2 down. Again, you should say it with me. We're going to leave everything inside the parentheses alone. Leave it alone to the 1, and we're going to subtract 1/2, so we get negative 1/2, and then we're going to multiply by the derivative of the, let me erase that line here. We're going to multiply by the derivative of what's inside the parentheses. And again, ladies and gentlemen, this is where 1 is 0. It's really nice to know the derivative of 1 over x. really quickly, because when you're taking calculus exams, when you take the BC exam in the spring, it's nice. Things like this just helps you pace yourself so you don't run out of time. You don't run out of time. And then this little thing right here. So look at this guy. So everything except for the -1 is in the denominator, right? So we got a 2, because these are all fractions being multiplied together. So I got a 2 here, I got an x squared here, and then I've got this underneath the square root. All right, so there is our answer. Again, or y prime is equal to -1 over 2x squared, square root of 1 plus 1 over x. Now, some of you is like, oh my God, we have a fraction inside of a fraction. They're not going to care as much in BC. I would imagine not so much, because it just takes a long time to do. When I teach this to my students in school, I do show them how to simplify this, but right now I'm not worried about that at all. We're just going to be okay with what we do here. All right, so this is the answer that I'm okay with. Because again, this video of this lesson is just to make sure you understand how to take derivatives. I'm not worried necessarily about the algebra skills to simplify this so we don't have a fraction inside of a fraction. All right, you got it? I think you do. Let's go ahead and look at example number 4. So this one looks pretty fun. I will tell you, if you have tried this or about to try this one before I do it, do not simplify. Just find the derivative and be done with it. All right, just the first line. So whatever you write right here is good enough for me. So we're going to go ahead and put the 8 down. And again, ladies and gentlemen, this is where students get confused, because now everything in here was raised to the 8th power. So we leave everything alone, including this piece here. And that's the problem that students struggle with. They want to do it immediately. Everything is raised to the 8th power, so that's our very first step. So just be careful when you do that piece of the puzzle. Now I'm going to look at what's inside of here, the derivative of this. Well, the derivative of 3 is, again, 0, so I don't care about that. So now I'm going to find the derivative of this. Well, again, I got to move the 5 down. And just like before, ladies and gentlemen, we're going to leave what's inside of the parentheses alone. 3x minus 2x, 3 cubed, my goodness, 3 cubed minus 2x to the 4th power. And we're going to be done with that. And now our attention goes to this guy, to this. And now this is going to be 3x squared minus 2. Now students, and this is, again, I know the kind of questions that students ask for these particular examples, is why now do we not go and do times 6x here? Well, the reason why we don't do that is that we're not going to keep going down, because eventually if we keep going down, 6x, well, the derivative of 6x is 6, the derivative of 6 is 0. There's no power here. There's no power up here, so we don't need to do this again. This is it. This is the derivative. So we're good, because students always get confused about, okay, well, you did it here. Yes, because this was raised to a power. This whole term was raised to a power. Well, now this little guy was raised to a power. This guy's not raised to a power. So you stop. You're good. We're happy. Okay? We're happy. We're happy. We're happy. So there is example number 4. So, and that's it. We're leaving it like that. There's no reason for us. I mean, the only thing we can really do is just, put the 5 with the 8 and then distribute that here. But who cares? We're good. Okay, we're good. We're good. We're good. So last one, I think you guys have it in you. Here we go. Find the derivative of this little crazy thing right here. So there's 2 ways you can do the problem. There's 2 ways you can do it. So the first one is, and my BC kids, you guys are intelligent people. So really what we have is we have x minus 1 to the 1/2 power, and that's this little guy right here, right? That's this little thing. And then we have it also raised to the 1/2 power, right? So students know the power of exponents for this. We know that f of x is equal to x minus 1 to the 1/4 power. So that's it. So this crazy looking thing right here, sometimes using algebra skills, power of exponents, is really, really helpful. Because now I got to find the derivative of this. Well, how easy is that? So f prime of x, well, it's 1/4. Leave what's inside the parentheses alone. I know you guys are getting really sick of me saying that. You're going to subtract 1 from 1/4, and then we're going to multiply by the derivative of this. Now, this is that example where it really doesn't, if you actually forgot to do the chain rule, it's not going to matter, because the derivative inside of this is going to be just simply 1. And that's totally fine. Sometimes that's how it looks up. And for this particular problem, we're okay just leaving it like this. Okay, like this. And so that's the easy way to do the problem. We could do it the other way, the very long, crazy way. and say, okay, well, the derivative is going to be, because remember, I'm just looking at this, so it's 1/2. Leave everything inside the parentheses alone to the negative 1/2. And then I've got to multiply. Now I got to take the derivative of this little guy right here, right? So I just took this one. So again, it's going to be 1/2 x minus 1 to the negative 1/2. And then I'm going to also multiply by the derivative of this, which is 1. And when this simplifies down, hopefully you guys can see this, when this simplifies down, you're going to get this particular problem. You're going to get the 1/2 and the 1/2. So let's actually simplify this. So f prime of x. So 1/2 and 1/2 is the 1/4. So I'm going to go ahead and cancel this out. Well, clearly I don't care about this 1. So this is going to be x minus 1 to the 1/2 to the negative 1/2. So this right here is going to be x minus 1 to the negative 1/4. We're going to move that down, right? Or we could even think about it like this first. So we have this. Well, remember, when you have x to the a times x to the b, goodness, can't write. That's just x to the a plus b. So we're gonna add these numbers, which really we're subtracting them. So this is going to be x minus 1 to the negative 3/4, and then we move it back down and we get the answer right here. So there's a happy way to do it, this little guy right here, and there's a little bit more complicated way to do it. Because when we give you guys questions, when the test gives you guys questions, this is going to be the form that they're going to do. Now, we're not going to give you guys something as insane as this right here. Oh God, just marked it out. As insane as right there, it's just going to, and if they do, then this is going to be the answer. This is going to be the answer for you. All right. So there's the chain rule. It's awesome. That's the chain rule. So what I'm going to have you guys do now is there's going to be a little assessment that is, it's not hard. Don't worry about it. That you're going to be working on to make sure that you guys are understanding this lesson. So lesson 4 is done. I hope you guys were able to understand it well, and I'll see you guys in the next video.